Hi friends, welcome back to my channel Testing Mini Bytes. I'm your friend Amnon Saktivel, and in this video we're gonna see about factory design pattern. Again, the design patterns, whatever we are going to cover, is not very specific to a particular language. Again, I'm gonna cover in Java, but it can be extended to any other languages of your choice. Okay. Again, most importantly, we should not try to force fit a design pattern into test automation. Good. So in this video, we will see about factory design pattern. And then before that, we need to understand when we have to use it, right? We should not forcefully try to fit a design pattern into the test automation framework. So the factory design pattern is a creational type of design pattern, which, deals with object instantiations, right? So we're gonna use this where we need to create certain type of object. What type of objects? Okay, it is used to create a different implementation objects of the same type. Okay, so if you have a super class or an interface that has a lot of implementations, then you also don't know what type of objects that you're going to create for them. Okay, I don't understand this. Okay, let me give us very simple example. Okay, with a diagram. So let's say you have a super class or your interface. It's your a lot of you have a lot of implementations as well, and then the client may decide what kind of implementations he wants to use. So okay, I don't understand again. Okay, let's take a very simple example. We have WebDriver, which is a interface, and it has a lot of implementation like Chrome driver, Firefox driver, Opera driver. So that in test automation framework, the client will choose in what browser they want to run their test, right? So if they want to run it on Chrome, we give them a Chrome. If they want to use Firefox, we give them a Firefox browser to run the test. So basically we only come to know that they want this type of implementation, Chrome or Firefox or Opera, only at the runtime. In those cases, this factory method will be really really helpful. Okay, we're going to achieve that in few minutes, but to give a high level understanding on what is factory design pattern, it's a creational design pattern which can be used if you want to create a different implementation objects for the same type. Okay, so first one, we're going to use it with a simple factory method, and then we'll also extend in with a supplier interface implementation in the next video. But for now, we will cover a very simple implementation. Good. Without wasting much time, let me go to the IntelliJ IDE. Again, here if you notice, I have created some very simple test cases, okay, in order for to use the factory design pattern. Okay, I have created very simple test case. So it's a factory method test that comes, gets the what kind of browser it needs to run from the data provider. Again, you can add more data, like Chrome, Firefox and all of the stuff, but for now I'm just simply returning Chrome, so that this particular test will be run only once, and the client is sending, they want to run the test on Chrome. Okay, now we have written certain logic like this. This is a normal way of we doing it, right? We initialize our WebDriver reference, and then we are comparing whether the browser they want to open is Chrome. Then I do this logic. See, this is the logic that is used to create an object. Okay, now if it is Firefox, this is the logic they use to create an Firefox object, Firefox driver. And what else? If it is Opera, they want to do like this. Okay, so again, you can also have a else block and then give some default implementation, but this is very simple use case where I'm comparing and providing the logic. But if you notice, this makes my code very clumsy. And then if there is a new requirement, I have to go and add another else block and keep on adding it. So what is the problem with this approach? One of the problem that I see is, this is for this particular test case. If I create another test case, then again I need to write the same piece of code. So actually you are writing same lines of code again and again. Okay, then what I can do? Okay, then what I will do, instead of using factory method, what I can do, I will just create a new method. I will extract it as a new method, and then I will call it. Suppose if I create a new test case, okay, if I create a new test case again, okay, if I create a new test case again, I will still use this. Okay, that is fine. I can use this. Why I have to go for a factory method design pattern? Okay, this is fine until now. But instead of this particular class, in the next class also you have to use it. Again, you have to write this piece of code there. So what if there is a better way to handle it? So this is when the factory method pattern comes into picture. Whatever the understanding you have is correct. Just the one thing is wrong, which is having them in the same class. Instead of having them in the same class, externalize the logic of creating all these things. Okay, take this hard part. Okay, there is complexity involved in creating all these objects. Take this away to another class, and that's what we are going to do with factory method design pattern. So what I can do, I can go to the main Java, and then maybe I create a new package. Okay, let's say it is factory, and inside factory I want to create a new class. Okay, let's name this class as a driver factory. Okay, now I have externalized this particular piece of thing. What I have to do, I have to copy this particular code. Okay, so cut this instead and then paste it here. That's it. We just moved the code away from there. We are not using any complex logic. So now it is asking, okay, I don't find this get driver method. So what we have to do, we have to, okay, you can change this to static. Okay, and then we can tell it's available in driver factory. That's it. Just import the class, everything is done. Now it is still showing error. It's telling has private access in. Okay, we have to change this to public. Okay, and this class is just having only one static method, so there is no need for to have a to expose my constructor. So what I can do, I can create a private constructor and shield people from creating objects for this particular class. Okay, and now there is no errors. Okay, and this again, I can remove this test. We are not interested in this now. So now this code has become very clean, and whatever we have achieved is called as factory design pattern. So it's as simple as that. We have moved the just the logic to in an external file. So my test don't bother about how that object creation logic. It just deals, okay, I pass this information, which browser I want, you do all the hard work, give me back the driver. That's all. So now if I run this particular piece of test, it will still work. Okay, the only thing we did is we just moved to an external class, we shield the constructor, we have created a method that is factory method, and then we are calling it. That's it. Okay, now you can use this particular piece of code in anywhere in your test. Even if you create another class or another test case, that doesn't matter. So everything is working fine. Okay, that's it, guys. So to give a quick recap, so we have one private constructor, and then we have created a private constructor so that they don't have to create an object for this. And then we have exposed a static method where the client can just pass what kind of objects they want, and based on the objects we will have all the logics within ourselves. Again, there is also a problem, like we can optimize this piece of code. We will do that in our next video. I think this is very easy to implement in our code. We'll try to see more use cases about it. I'll see you all in another great video. Until then, tada, bye bye from Bye.